It'll be fine. It'll be fine.
Shema.
We can see you. You might want to kill the Pornhub tab.
Yeah, Mark. Yeah. All right.
Hello.
Hello. All right.
Right. Mute your mics, please. It's
I'm just checking out.
Sean and myself doing the talking.
All right.
And his kids in the background.
You tell them, Mark. All right. So thanks everyone for coming. This is going to be an introduction to CSRF or XSRF, Cross Site Request Forgery. If I can actually log in.
It's also an introduction to the idea of CSRF and also Sean's mechanical keyboard.
Mark loves my keyboard. Mark has a thing with mechanical keyboards. All right, cool. So I'm starting a few things up here, just to show you what tools I use. So I use a web browser, Burp. These are just going to be used primarily just to see the traffic, view the traffic. Essentially, to exploit CSRF, you just need a web browser, a web server, a web browser, and that's about it. I mean, you can monitor a lot of the stuff using developer tools. Just a proxy like Burp makes it a lot easier to visualize.
Sean, before you continue with your demo, would you mind giving a brief explanation of what CSRF actually is and why it isn't the same as cross-site scripting?
Yeah, so that's one of the things I'm going to do is I'm going to load in a session here, and I need to do this so you can actually see what's going on here, and then I'll explain it. So let me log in. Very strong username and password. Okay, hopefully I'll log in. Okay, now I'm in. So what I want to do is I want to go view the traffic. Oh, gosh. I'm not going to Burp. Sorry, a few things here. All right. So we can see a bunch of traffic. Now, the important thing to note is this JSession ID, this cookie. Now, HTTP, the protocol, which HTTPS relies on, is a stateless protocol. What that means is if a server receives a request, it has no notion just based on a HTTP request that request belongs to me, that I've just logged in. The protocol itself. So what has been done is the notion of a session. And traditionally, those sessions used to be cookie-based sessions, which is exactly what this is here. So what happens is, actually, let's do this. You might see this a lot clearer. This is kind of going into session management. What I want to do is I'm going to clear this. And when you hit the server for the first time, typically you get a new session. So if I hit the server, you'll see I have no cookie sent, and it typically has a cookie set in the response. So this telling your browser, hey, set the session cookie to this. The path, that then indicates to your browser which path this cookie should be sent for. So all requests on the web go path. And HTTP only. HTTP only indicates to the browser that JavaScript should only interact with this. And this is where some of the similarities of cross-site scripting comes in from last time we talked, where if you have a cross-site scripting vulnerability, you can steal this cookie and then start using it yourself unless you have the HTTP only flag set. Now, CSRF is totally different. It leverages the cookie. So this cookie tells the server that I'm a user with this session. So once I log in with web goat and web goat, you might see the session cookie change. Sometimes it should change, sometimes it won't. Typically you do want to renew the cookie when you authenticate, but in this case it hasn't. Not too worried, it's not a very sensitive app. But the important bit is I have a unique piece or unique ID that I can associate that request to with a session on the server side. And the session is something that the server has allocated knowledge of a end entity. So be it a service, but typically a user. Now, this is all important because the cookie is sent with each request that's set in the path. And that means if your browser makes that request, this cookie will be sent. And that means that request will be done as part of that user's session. Now, this is a problem because the server just sees a request being made with this session ID and says, okay, this request is made by WebGoat in the case that I logged in here. So I'm going to say, okay, that action is WebGoat's action and approve whatever is requesting. And you'll see in a bit why that's a problem, because if I can get your browser to make requests, it will do things on your behalf without your knowledge. And this is where the Cross Site Request Forgery comes from. It's, you can have another site perform that request on behalf of your web browser for another site that it doesn't belong to. So if we come to the examples, which is, I don't know why that's all weird. Let's see if we can get it. Okay, didn't like that. Web. So in here, here's an example in the Cross Site Request Forgery. Simple, type in the message, test. This is a test message. Okay, and as you see, it's a simple post that has the title and message that creates a new message on the server, and it's associated with that user because they're using the session ID. So if we go look at the actual request being made, this over here, we can see there's the request. It's a post with a title, a message, and this is pertinent to the actual web app and the session ID. Now, if I can get your browser to make the same request, I can create a new message from another site. And that's exactly what I'm going to do. So what I have here is a page that I've set up on another server that we're going to use to perform a cross-site request. So a request to another site that doesn't belong to that specific site where the page has been served. So let's copy this. This is not going to work. I forgot copy and paste doesn't work between this. So I'm going to have to type it, sorry. So title equals CSRF rules and message equals this is and submit. Okay, so we're going to make it to the site called training. And WebGoat attack (207) 8372 and menu equals 900. Okay, so just going through this. So this is JavaScript. So JavaScript's a really good thing to make these cross-site request forgeries. So you're using JavaScript to generate the request and then send it. It's using this XML HTTP request object, which is basically a way in JavaScript to generate a request and then send that request. So in here, here's the post. So this is the body that we are going to send, which kind of matches that. I should probably put plus, because that might not work. The URL that we're going to send it to, this is generating a new object, saying it's post. Now the important part of this is true. Actually, sorry. The important part is this one, with credentials equals true. So what this tells the browser is, send any cookies associated with this site. And because we said /webgoat, that means this JSession ID is going to be sent as long as it's done in context with the browser that the user's logged in as. And then other things like the content type and the content length, which is from the body. So if I've done this correctly, which I hope it's going to work, what we should do is now, as I said, all you need is developer tools. I'm going to use developer tools just so you can see it in action. So if we go to call, cool. Okay, so that does exactly what I wanted to. Sorry, I was trying to find a funny message image, so I don't know if anyone finds that funny, but
no.
No. Oh well, I failed. So it's important to consider this in terms of a user, right? So a user is going to go, hey, check out this funny meme of a dog hacking a computer. It's like, oh, awesome. Let me go look at it. They're only going to see this. They're not going to see these requests. Now, the important thing is this request here. They're never going to see that. And that is made from call to training.shawnwright.com. That is a cross-site request. It's made another request. Now, also important, if we go view the logs, is we should see this request being made as a post. And look, the session ID is being sent. Now, the server is going to see this request coming in, and it's going to see the session ID and go, okay, this is a legitimate request. So I'm going to do it as webgoat who's logged in with that session ID. And as you can see, there's the response. So what that means now on this page, if I refresh it and I've done it correctly, there should appear a new message. There we go. CSRF rules. So by visiting a malicious site and being logged in, I've now created a new message without the user's knowledge. They had zero visibility. Like just to prove the fact that you can't see it. There's no, you just see the image. And if I come back to the site, there should be another one there. There we go. Now, this is a banana example, yes, but can you imagine this is your online banking? And you say, hey, transfer these funds to this account, $1,000. It suddenly becomes a problem. So, before I move forward, sorry, I'm just going to see if there are any questions or comments.
I've got a question for you, Sean.
Sure.
So, the issue of CSRF was an OWASP top 10
Yes.
problem, certainly in the 2013 top 10. I think it weighed in at number 8 in the charts. But in the 2017 OWASP top 10, it was completely removed.
Yep.
So, what are your thoughts on why that was?
Okay. So as I said, this is kind of a legacy way of dealing with session management. This is very much the architecture where you have the session management being handled on the server. The server generates the session ID, in this case the cookie, sets in the browser then sends it with every request.
Yeah.
This is changing. One of the problems with this way of doing it, especially if you have load balanced applications or even applications spinning up and spinning down, you need some central way of controlling that session management. Imagine you have a session created on a server that suddenly disappears. Well, guess what? That ID is no longer valid. So how do you maintain that? So it adds a lot of complexity in the back end. So what a lot of applications are doing now is they're doing away with the session cookie. They are generating what's, I think this is the right terminology, a client-side session management, where a token is just still generated on the server, but it's sent to the client, and the client is responsible for sending that token and maintaining that token. And then the server will just validate it. And one major advancement in this is the JWT token, JSON Web Tokens. Within that, you have it's a RFC spec, there's a format to it, but the important thing is that token can contain information such as the user logged in, permissions or roles or whatever. Like, it's a really flexible format, so you can have JSON payload in there that's really freeform, and then you have a signature that makes sure that it's validated, and that's where the server side does the validation, and that is all handled by JavaScript primarily. So that JavaScript is responsible for sending that token, storing that token. So if you have another site calling that request, it's not going to take place or it will take place, but it's not going to be valid because that token requires something on the site to actually send it. There's another thing, and this is where I can show this now as well. There's something called CORS. Now, CORS is important for CSRF because it blocks many requests. One of the things around CORS is the basic, I forgot what the term is, the simple request method type. So basically, I think the content type needs to be application and XSW, this one, yeah, or application text. I think it's the other one, and it must be a post or delete and get. If it's not one of those, it's considered another method, and it will then perform the cross-origin resource sharing pre-flight check, and that effectively kills CSRF. I don't think that's by design. You should never rely on that because that's not really designed to impact CSRF, but it does have that impact. So I know this does impact it. I think this might work. So if I come here and I do a request, okay, so not post, sorry, I might need to do a get. I did have it working the other day. Maybe a get. Even a put might even work. No. Gosh. So this, there we go. That's what I wanted to show. So see this, I had a put request method, but you see this options request or response. And what the pre-flight does is it basically asks the browser, like, hey, for this domain, can I do a call? And the server will return a header saying yes or no. And in many cases, that's going to fail. And the request, the cross-origin resource request, as in this case, won't go any further. So it's kind of effectively killed it. it's not a mitigation. You shouldn't rely on it, but that's something that does impact it. I've had several vulnerabilities like, yes, I'm going to be able to do Cross Site CSRF vulnerability. Like, as you can see, it goes no further. And then I hit this, and you can see method not allowed, and it goes no further. That answer your question, Mark?
Perfectly, mate. Thank you.
Cool. All right, so there's some other questions in the chat. Yes, so same site cookies to defeat CSRF. Same site cookies is a new flag on cookies. So cookies have 3 flags at the moment. Before same site, there was HTTP only, which we've seen. That tells the browser this cookie can only be submitted with HTTP requests. So things like JavaScript, in this case, the one that I did before, you can't use JavaScript to interact with that cookie. And then the secure flag, that tells the browser that that cookie can only be sent over HTTPS. Now there's a new flag called same site, and basically what this is, there's different formats. There's lax, there's strict, and there's none. And it tells the browser when a cookie can actually be sent to another, when it should be sent. So I forgot the exact values and what they mean, but in summary, none, I think, means as it is today. Lax, there's some weird time dance thing, and strict means that cookie will only be sent for requests from the same site, hence the name same site. Now the problem is, and the biggest problem I have with this new cookie is, there's no way to have a whitelist. It's all or nothing. So if I want to allow a request to be sent from one site to another, I then have to allow from any site to that. I can't have a whitelist saying only allow that cookie to be submitted to these domains. So that becomes a problem when you now have that set. You need to do a cross-site request. I'm not going to say forgery, but you are actually doing cross-site requests between 2 domains legitimately. But you then open that up to CSRF, because guess what? You can't control what sites should be able to do that legitimately.
Yeah. And with Chrome making the changes around same site cookies, enforcing quite strict rules, the problems or the pain points would occur where you have things like iframed third-party websites in your own website, and also where you redirect back to your own website from a third-party website. So, for example, in a payment system where you maybe go to 3D Secure as part of the validation of a payment, and then redirect the customer back to your website, that's where it can present a problem. And in my organization, we saw that was something we had to fix.
Awesome. All right, I'm going to try this. I did try it the other day, and I got it to work eventually.
Live demo's going quite well so far, mate.
Don't jinx it.
Shit.
I think it's this. I hope.
I've got a whole bunch of questions for you, Sean, as we go on.
Yes, far away. And if anyone else have any other questions, just far away as well.
While you're doing that, I'll ask you another one. In your experience, I know the answer to this because you and I are both AppSec people, but for the benefit of the people listening, in your experience, where do you see this problem the most in terms of software footprint? So I don't see it very often. That's possibly because predominantly the software that I care about is Microsoft and ASP.NET. But I can imagine it's a big problem in things like Java and in PHP and stuff like that. So what are your thoughts?
Yeah, certainly, I think things have improved along the way. So frameworks do a lot of things. I know Spring, for instance, as anti-CSRF measures, which I'm trying to get to show. Does that have that in place? But certainly, basically any web application that generates a session in a cookie and sends that is potentially vulnerable. Relying on cookies is kind of the whole crux of this vulnerability.
Yeah.
I'm hoping this works.
Just gonna build on the question that Dave has asked. So he's asking, what do I look for to determine if a site is vulnerable to this sort of attack? And I guess it goes back to my previous point around, well, if I build ASP.NET applications, then actually you get a lot of out-of-the-box security around forgery. So, for example, IIS versus your web application kind of work quite well together when you've got things like login forms and contact us forms and all that kind of stuff. But, I mean, my thoughts are you can run a scan, and a scan will tell you if there is a CSRF vulnerability. But any more thoughts on that yourself, Sean?
Scans can help with that. But generally, and this comes to the mitigation that I'm trying to get working out. I did do it yesterday.
I'm filling for you here, mate. I'm filling.
I think I got it right now. Yeah, there we go. That's the one. So basically, what you want to do is see anywhere you send in these session cookies, but no other information. And it's, as I said, it's got to be a simple request. I think that's the term they use. It's basically. Also, remember, things like get aren't really useful. Cross Site Request Forgery is not very good at trying to get things because of browser limitations. You're not going to be able to submit this request and then pass that request unless they have wild cause policies that allow anything. Then it could be possible. But it's anything that really does modification. That's primarily the attack. So anywhere you got things like creating accounts, modifying accounts, just basic any addition or manipulation or deletion. Those are generally going to be areas that you need to focus your CSRF on, and those will typically be post requests. Some people might use GET for them, but typically go post. So post request with a session cookie without any other information, which is what I'm trying to show here, which you'll see. So how you mitigate this? We've already spoken about same site. Same site is great mitigation if you don't need any other site to communicate with your site. So you'll put strict as your same site. And that means any other site that tries to do this request will be blocked by the browser, or should be coming. I think most browsers support it now. There are different patterns out there, and one of the ones this is going to illustrate is the anti-CSRF token. Now, there should be a token in here somewhere. I think that's it. Let me check. If I submit a query from this, there should be a token submitted with this query. No. All right. Any other questions? I think that's working yesterday.
Yeah. While you're doing that, Sean, another question from Dave. Follow-up question is around how does an attacker determine that a site is vulnerable to CSRF?
Yeah.
So is it guesswork? Do they go, well, I'll try and steal this session or steal this cookie, and it works great. It doesn't work. Well, shit, I'll move on.
So it's. Oh, I had the wrong menu ID.
Cheers, Dan.
It's doing what I'm doing. At kind of over here. All right. You try to do the request from another session. So you don't have to do this from the server. You can just create a local HTML file and try to do it. That's probably going to be the best way to test it. You're going to not always win. You're going to see things like cause and that. But this is the way I typically do it. I'll just create a simple page, make do a simple HTML page locally, open up in my browser, and see if the request is submitted. Hey, I suddenly have a new account. Great, it's vulnerable. As I said before, looking for things like, are you doing a post request with a session cookie but not sending anything else with it? It's kind of a giveaway, and then you do this just to test it and confirm that. Hopefully this is the right one. There should be some other. Yes, this is what I was looking for. Okay, so now you'll see there's a new input parameter called CSRF token. And what I want to do before I go into that, let me show a request without me submitting that CSRF token.
Just a quick question there from GOS. Does keeping the software stack up to date prevent CSRF? Well, not really. The stack's not the problem, it's the code.
Yeah, it's certainly, the implementation. I mean, some might. Okay, so wait, let's rephrase that. So if this is like libraries and frameworks and that, some might implement CSRF anti-CSRF mechanisms automatically, but seldom do. It's more on the developers and that to do that. If it is software, on the other hand, like a third-party off-the-shelf solution, then yeah, that should probably be the maintainer or the vendor that does it, and then making sure you have up-to-date stuff.
But it's the same. It's the same problem though, but it's their problem rather than your problem.
Right. They all need to implement the fix and
yeah, exactly right.
All right, so that's not the right version. I want this one. Sorry, I'm trying to multitask here and get. It's annoying not having copy and paste. Attack. Screen equals 147.1.1.471.01.
Sean's going to tell us how we prevent it, Geo, so don't you worry about that.
And equals 900. And
switch off the computer and problem goes away.
Something like that. That will work. You might have very upset customers, and rightly so. Okay, so hopefully this is not going to work. Right, so if we go in here and I do this, did I change? I don't know.
There are tools. I mean, in fairness, there are tools out there that will help. Anybody that knows me well knows that I'm a big fan of Sean.
I don't know. Is it maybe NetSparker?
That's the one. Yeah. Yeah. WAFs are great too, but NetSparker is a fairly well-established, market-leading web application vulnerability scanning tool. It will test for CSRF. Burp does the same. Dan's correct. I believe Zap also will test. In fact, I know it does. So there are tons of tools out there that you can fire at your websites, and they will detect and report on potential CSRF vulnerabilities. So that takes away a bit of the heavy lifting. So you don't have to go manually test everything to find out whether you've got issues with anti-forgery tokens not working properly and all that kind of thing. It'll do the work for you. But you've still got to then go away and work in your software and probably on server side a little bit to fix the problem. So, Sean, did I fill well there?
You did.
Fantastic.
Okay, so we can see this example. Hit the page. It's submitted that post to another site, another training site, and we got a 200 back saying, "Hey, everything's fine. Great. I have transferred the funds to the account that I wanted to, and I'm now rich." So how do you prevent this? Well, I already touched on this. There's an anti-CSRF token. I sometimes call it CSRF token. I call them anti-CSRF token because to me they prevent CSRF. But anyway, it doesn't, terminologies I don't think it's too important. The important bit is there is a random value that's put into the portion of the site where that request is being made. So in this case, we've loaded this page here. Let me try open it again. This page here, and within it, oh, someone getting in trouble.
This is the new normal, Sean. Don't worry about it.
Yeah. You'll see there's a token within that, and that should be unique. You could make it unique per request, but this is going to cause problems with browser history and going back and that. Or what's suitable is unique per session. And it needs to be random, so the attacker can't guess this. And when you do the post, you're going to actually submit that token with that post request. Now this breaks the attack because the attacker has no way of knowing this token. So they can say transfer the funds and say submit, but they're not going to know this token. So they won't be submitting that token. So if we come back to my example, and I'll now change this to be that ID at the top. What's it? 803, 803, 158, 158, 781, 781. Save that. And if we now come here, refresh the page, we should now hopefully get a invalid. Maybe that didn't return an invalid thing. Yeah, so I don't know what's going on, and again, this is going to very much depend on the server and how it implements the check. Typically what you want to do is probably return a 404 or something like that to their request, because this should return an invalid request. Just send it to the repeater. And this again is how you can also test, just by doing a post to the server with the cookie. And again, we should see this, but this is not showing up. I don't know why that's not showing up. I should have tested this, but the idea still remains. The server needs to validate that token and make sure it's sent with the request. And if it's not, return an error. If it's not the valid token, return an error. Maybe this just returned a 200 and it didn't update the funds or whatever. But that's one method. There are several. There's like double submit cookies and other things. OWASP has a whole bunch of them. This is probably the most common. So you'd find it in the form fields. You can also find it in the response header. So you can use JavaScript to pull it from the response header and send it with the next request. That's something else I've seen. Some of the libraries actually, I think Spring does that as well. Any comments on that? I'm just pretty curious why that still went through. Oh, anyway.
Just while you're doing your next thing, Sean, just a little comment on scanning tools. There's been quite a bit of a chat around that.
Sure.
Yeah, there are tools. I mentioned 3 previously, and NetSparker being one, OWASP Zap being another, and Burp being the third. You know, they are out there. Burp Community's free, Zap's free. They're all entirely great products in their own right. NetSparker is a commercial product. It just happens to be a product I've been using for probably nearly 9 years, 9 years, something like that. I guess you go with what you trust, and that, because I've had that relationship with NetSparker for a long time, I trust the product. More broadly speaking, there are things like Nessus out there, which is a tenable product, and Nessus on-prem is not massively expensive. You're talking about £2,000 per license, and that will do infrastructure and everything really. But it does web app. Qualys is out there, but in my experience, Qualys is incredibly expensive, particularly if you've got a large footprint, host footprint, particularly. Now, Nessus and Tenable.io and Qualys both all do web app scanning, but they don't come into the market from a web application security background. They come in from an infrastructure background. So their forte is predominantly looking at hosts and security on the hosts, be it through port security, because they all run fundamentally they all run Nmap at the end of the day. But NetSparker and Zap and Burp and so on are all web app specific, and they've been designed that way, which is why, in my experience at least, then somebody mentioned complementary technologies. Then yes, that's a good idea.
Yeah. So you also got to remember what I mean. Qualys does have a dedicated web app scanning, but also the vulnerability scanning does touch on some web app type stuff as well. Ultimately, you got to look at the product, evaluate it for your needs. NetSparker might not work for everyone. It should work for most people. I found it a great product. It's ultimately why you and your org need to go out and evaluate these tools yourselves and see what works best for you.
I think so. But I also think, again, going back to the idea of complementary technologies,
Yep.
The idea that you blend different tooling into your testing program is really important.
Yes.
Because I could point Tenable, I could take a single web application and point Tenable, Qualys, and NetSparker, and Zap, and Burp at it and go, right, go knock yourself out. And I guarantee you I'll get 4 different responses.
Yep.
4 different sets of results. Yeah.
Yep.
So the idea of using a scanner is to take the heavy lifting out of testing. It's to give you a triageable report of information that you can then go away and do some more manual investigation. Scanners aren't pen testers. They're not robotic pen testers by any stretch of the imagination. They're there to simply do a first pass analysis of a web app or a server or a network or whatever, and then present you with some findings that you then go and dig into more with more analysis. Okay. So I guess the conclusion there is don't rely on a scanning tool to help you out the shit. Rely on it to help you find the things you need to investigate further.
Yeah, exactly.
And scanners won't find IDO. You're absolutely right.
All right, so coming to the close, what I want to show you. So, Mark, you asked about CSRF and finding it. There's one. There's another one somewhere. I think there's another one. So you can see there's another one. So you can see it's quite prevalent, along with cross site scripting quite a bit there. But what I wanted to show is this is prevalent in many apps, including Carbon Black, which is a security product. They were great at fixing that, by the way. The one that I'm probably the most proud of is a TPLink. So this was a router. And to me, this is the thing that's probably the most concerning, just because of the implication. So what I did with this router is I did a research on it. And if we look at the actual disclosure, I'll come back to the proof of concept. There was a page on the router where, if I zoom in a bit, there's a remote management IP address, and 0.0.0.0 means no remote management. Okay, great, can't access this. Outside of my home network, everything's fine.
This demo, because this is the idea that if you've got your remote admin interface available on your router, then you're screwed.
It gets worse than that.
Yeah, screwed's pretty bad. I mean, which kind of way of screwed do you want me to say it?
Let me show you why it's worse than that. Okay, so here's a site. I visit, a cute dog with his tongue hanging out. Great. Typical users won't see this. And in the background, you see there's a few requests going off to a 192.168.0.4, which is a private IP, which turns out to be the router. And you can see there's a few gets and posts and what's going on. You go back to your router and you suddenly see, oh, that's 255.255.255.255, which is allow any
Sean is doxing his employer right now.
Which is allowing any IP address to access the remote management. And what this vulnerability is a CSRF vulnerability. So if we go back up to the proof of concept, you can see this lovely image. That's just a simple image tag. But all the real juicy stuff happened in this JavaScript. Now, I'm not going to go into too many details of the JavaScript. It's all there available. If you want more, I'll give you the link. But the simple process was, this router has the ability to save your configuration to a file, obviously for backup purposes, and then re-import configuration into your router, and hey presto, you've restored your router configuration. Well, I, as an attacker, if I have the ability to upload a configuration file, I can control that router and change any setting I want to on that router. Well, guess what this proof of concept does? It leverages just that. It takes a file hosted on another server. This took me a while to eventually get working, but I eventually got it working, which is why I was so happy with this vulnerability.
So hang on, Sean, hang on. Sorry to interrupt you, mate. But are you telling me that you can change the DNS settings on my router? And if I go to facebook.com, it's your facebook.com?
I could change your gateway, which is where your router points to and connects to for the internet.
Oh my God.
I could change your DNS. I could any setting on that router I could have changed, including the admin username and password. So this bit here basically took the file, uploaded it to the router, to this request here, and you can see it's a post, and then it did another request to reboot the router, so the changes took effect immediately, which is why there's a sleep, because that's needed to upload and do its thing and then reboot the router. So if you were logged in as the admin user on your router and you visited this page, I would upload a configuration of my choosing to your router and control your router. But I think I put in here, or might have tweaked it better further before. No, actually I did, right here. Because people always change their default credentials on the routers, right?
No.
I took this a step further. So routers use basic authentication, and with basic authentication, you can actually force that in the URL. I logged them in for themselves. So if they hadn't already logged in, it would log in using the basic credentials, assuming they hadn't changed the router configuration. We know the IP because, again, people generally don't change router configuration. So I certainly have the ability to own your router through a CSRF vulnerability with you just visiting a single page. And that's why I love this vulnerability, because
you can alter somebody's life with this vulnerability quite significantly. And for those that don't know where I work for an ISP, and of course routers are what we ship out with every broadband connection that we sell to people. And often, not so much nowadays, but certainly historically, you'd find routers by manufacturers like Zyxel and Netgear and people like that, where there were even hard-coded creds that you couldn't change, or at the very minimum, the default creds that Sean talked about a few minutes ago were just publicly available. You can just Google, Netgear model, default admin, bang, bang, bang. You got the admin username and password, and the customer would never think to change them. And so there you go. You've got pwnage, dead easy.
Yep. Yeah, and I mean this to me is all highlights how a CSRF and what an attacker could potentially do. Now, there's other vulnerabilities in there. Some of them were the ability to create an admin user. Those still relied on an admin user already logged in, because CSRF takes advantage of a user's existing session. So yeah, and all basic authentication does is really create a new session with default creds and then creates its own little mini session. This was fixed. The interesting way they did fix it, I don't think it was a good fix in my opinion. It still fixed it, don't get me wrong, but they looked to the referrer header. I didn't spend too much time to see if you could bypass that and all of that. I think one of the things in XML HTTP request is you can't modify that header, so I couldn't break their fix. It killed this vulnerability. They did patch it. Again, how many people patch the routers? And it kind of goes to that point asked earlier, like about updating stuff. Certainly in like this case, you would want to update your router. Visiting one site could own your router. So this was probably an extreme of CSRF. As we said, like CSRF is kind of going away, especially with the changing in technology to HTML5, more client-side sessions, same-side cookies. So it is a vulnerability which I think is slowly going away, but it's still very much there, especially with a lot older systems.
Agreed.
Cool. So I think that's all I had. Hopefully it's been useful for everyone. I don't know if anyone has anything else they would like to add or ask.
I think we're good.
Oh.
I think a couple of people asking whether I'm the guy in the PlusNet adverts. That's not true. I look a bit like him. I've got the same belly as him, but it's definitely not me. But yeah, test your software. Work with your people running your web server. Get a scanner involved if you can. Figure out anti-forgery tokens because they're really helpful. And you should be cool. Sean, what are we doing next, mate?
So next week I will be introducing certificates along with yourself, hopefully.
Fantastic.
And yeah, it will be just so people often see certificates and go, "Oh my gosh, certificates!" So try and get it. When you boil it down to its basic form, certificates aren't that bad.
They are. Just to GOS's point, top 5 security guidelines for secure web apps. The OWASP end of.
Yep.
Go away and read that. OWASP.org, and that's where your answers are.
You could even add SANS top 25 to that as well if you want to broaden the scope a little bit more.
Indeed.
Maybe overlap the two.
It's important. Yeah, it's a good point actually because OWASP distill the top 10 based on feedback over years. SANS, not SAMS. SANS. Yeah, that's the one. Cheers, Dan. OWASP take feedback and data from organizations globally over the period of years to look at what the main threats are that companies see and attack types and all that kind of stuff. And they make a top 10. And it's become kind of like a little bit of a Bible in many ways, for want of a better word. But they aren't the only 10 problems, it's fair to say, in web application security. There are many other ones out there. But you can't go wrong if you look at OWASP as the first port of call.
Yep.
Yeah.
That's good. And reach out to the community. I mean, one of the things that I've seen, and I've been in the area of AppSec for a while, and Mark has been as well, is things are evolving. I mean, we've just seen CSRF. It used to be like really big, and it's kind of falling away. But there are other things like with the notion of node and that template injection and that kind of stuff. So things are evolving. New technologies come out. New ways of doing things come out. So it's really important to keep up to breast and stay on top of things. And a really good way is to Dan said phone back short is to engage with the community. I personally find it a really good mechanism for trying to stay on top of things. You might be the one sharing the information, or you might be getting it from someone else. It's really quick, a lot more quicker than sometimes news.
Social media is good. Yeah, I agree. Being involved in things like Twitter and all that kind of stuff, which can have its pitfalls and it can be a bit dodgy at times. But generally speaking, if you're following the right people, then you've got a good chance of learning some useful information. I just want to pick up on one last point, Sean, from me about something you mentioned earlier around. In fact, you mentioned it again a couple of minutes ago around the third-party frameworks. That's where you're going to find problems. Okay, that's where we see problems with cross-site scripting, and also CSRF and other things besides, even SQL injection, where you write software and you embed dependencies in that software in the shape of Node or jQuery handlebars, flipping Angular, etc., etc. And you might have crafted your code particularly well, but you're borrowing somebody else's software as part and parcel of your deployment of your application, and then that software becomes out of date and becomes vulnerable, and that's where you have a problem, really. And in my experience of managing a really quite large web estate, I don't have a problem with our developers. They're writing good software. What they're not doing necessarily is keeping a check on the third-party components, and that is very much an OWASP top 10 problem and has been for a long time. So it's about keeping an eye on the things that you're using, not necessarily writing.
Yep. It really, at the end of the day, keeping up to breast on as much as you can. So libraries, vulnerabilities, technologies, frameworks, that kind of stuff. That this, while some libraries and that do introduce vulnerabilities, I've seen some frameworks that are doing an absolutely amazing job. Like Django is one. I tested the Django web app, and it just off the cuff HTML encode stuff. So things like cross-site scripting is almost impossible. Spring have a lot of things built into it where developers can leverage that, secure headers and that, just a one-line config. Things like that. I see a lot of power in frameworks, but at the same time, you need to make sure you update them because they do still contain vulnerabilities themselves.
Yeah, agreed. And so you can't resist the urge to say the following statement: patch all the things.
Yeah, or we've just seen salt.
Yeah, quite.
And that one was scary because when the news came out, it was like 2 days later, and then poof, suddenly Ghost was in the news as well as Lineage OS.
Yeah, agreed. Okay, I don't think we've got any more questions, Sean, for you. I think we're done, mate.
So one more question, report URI. So report URI is for CSP. So if you watch my video, our video from cross-site scripting, I talked a bit about CSP, and CSP does reporting, so that's where report URI comes into it. So if you can look at that, leverage that, that's not going to really help with CSRF. It's a kind of different type of protection than you need.
Yeah, agreed. I mean, exactly what Sean said. CSP is around whitelisting dependencies and making sure that you're only executing the things on your web app that you really want to execute. Report URI is great. I think if you're using ASP.NET, you get it anyway, so you probably wouldn't need to go out to report URI. But it is a good service. Yeah.
Cool. Well, thanks everyone. And thank you for attending. And as always, if you've got any questions, feel free to reach out to myself or Mark, and we'd be glad to help you.
So we're Sean WrightSec. I'm not. He is. We're Sean WrightSec on Twitter and AppSecBloke. So if you want to hit us up with anything you like, you're very welcome.
Awesome. Thank you. Have a good night, everyone, and a happy long weekend.
Yay! Cheers.
Cheers.
Thanks very much.